Alright, so I just woke up. I got 40 minutes before I gotta go somewhere. So we're gonna crank this out real quick. Um, Actually, I need to see what I was thinking on this. And then let's go, oops, to do. Okay, so put two hash tables. Okay, so I think what I want to do is hash tables. But the thing is, I don't think it's that difficult because what I'm thinking is a hash table. I mean a hash map, right? A hash map is just a hash table, but if you get the same key, if you get the same key, instead of just flat out adding it, you update the value that's there, and then you have the ability to remove. I'm pretty sure I should have added that in the hash table, but it is what it is. But let's verify that that's true. Right, so implement hash map, or how does a hash map work? I think is a better question. Internal working hash map, hash map. Bro. It's a very important question for interviews. For all the problem solvers out there, hash map is one of the favorite data structures, blah, blah, blah. Use for storing key value. Using hash table, only unique keys are allowed. Hash map doesn't guarantee the ordering of elements. You can't store multiple values in the same key. If you try to do so, the overwrite will happen. The old key will replace the new key. It is internally implemented using two data structures, namely an array and a linked list. Whenever you declare a hash map internally, it will create an array of buckets. The buckets are referred to as nodes. But why does it do that? Why can't you just use an array? Why does it have to use a linked list? Oh, okay. I see. Oh no. Okay, so just to make it quicker, they use binary tree, but I know I do not care. I can switch it out later. It's not that big of a deal. Okay, so we're gonna do this real quick. And then we're gonna make there a hash map. And then we're going to copy everything that's in hash table into hash map. Oops. Okay, we're gonna go in hash map. Okay. Oh wait, I did the wrong one. What the fuck? Move all that. Then let's, okay. And then now we can make the source for we can make the source for the hash map. Right. And then we're going to say the hash map this is just going to be, it's really just going to be a hash map or hash table, right? I think you interface that a certain way. Yeah. All right, so then we're gonna have let's make hashmap.h, and then we're gonna type that struct this here. Hashmap type def struct hashmap type to hashmap. And we're going to include this in here. Hashmap.h. Oh yeah, and then also need to include this is lib. Or do I need to go back another one? Lib slash hash table. Oh, source. Lib slash source slash hash table. Really? Oh, .c or .h. Bro, am I bugging? Live source. Oh, it's included. Duh. Include. And then now we can say hash map, create hash map. And then we're going to pass in a hash table. Do I need to? Now the question is, do I want to deep copy it into here or not? I don't think I have to. So let's just say we take in the hash table and then hash map output equals malloc size of struct hash map type. I need a and then we say output table equals table. Input, right? And then we just return output. What was the problem? Dude, I'm gonna lose it. What is wrong? So we have, oh wait, no, the wrong one. Elib, Hashmap, lib, include, CLH. And then from source, it's, oh. I'm a little bit silly for that. Let me see. Standard lib. There we go. Now we create it. Now, if you wanted to add elements, Hashmap, we can hash in Hashmap. Oh, you know what I need? I need actually, let me just go to the include file. Oh wait, I need way more than that. I need the map, and then how to do it in here. Then I did the key, and then I did the value, right? So let's first check if the value exists. So on map, on map table, we can then call find value. We need the table and then we need the key, right? So if this value is null, oops. If this value is null, right? If this value is null, then that means it does exist. And we can add an element to the hash table. Key and value, right? Else, we're gonna update a value. Yeah, so I need to do that too. Oops. Oh yeah, because it does this. Oh, I can delete this actually. Now that I figured that out. Alright, so let's do void update value. T. I need to change all those function names. So I was just trying to figure stuff out. So hash table, and then we say so we're gonna need the key and the value. So if we want to update the value, we would need to find that key. We need to find the key and then update it at that index. So for int I equals 0 while I is less than no, because you can okay, how to do it for find value? I'm pretty sure I wrapped it. Yeah, okay. These need to all be pointers. No, let's replace table with table. All right. Member reference base type hash table is not a struct. What? Oh, I didn't do it for all. Whoopsies. As table. Oh, so table. Actually, let's just undo this. Table for everything. Called undeclared hash key, right? Because this needs to be below hash key. Where is hash key? That fast? Oh, there it is. Yeah. So bool found equals false. And then we can say if it's found, if it's found, then table passes at or no, table passes a hash key num collisions. Oh wait, no, that's not right. Wait, let me remind myself what hash key does, or how hash key handles it rather. Oh shit, I did remove that, didn't I? There it is. Okay. Go to the end and then start 0 with the current offsets. Okay, so with the num collisions, if you pass it in multiple times, it will always return the same thing. So we can, to access it again, we can say the same thing. So hash key num collisions, and then table. Oops, that's not what I meant to do. Size. So this value is going to equal value. If it's not found, then don't do anything. All right. So table size. Okay, so that should be fine. Yeah, it's getting close, so I won't quite get as much done as I wanted to, but when I get back, I just gotta test it. Right, so we have update value, and then in the to-do, let's say current path. Let's first test update value any hash table. But let's just do this tentatively. So we'll have the address of map. Let's do this. Map table, and then we'll say we have the key and we want the value. So if it does not exist, add the element. If it does exist, update the value. Good. Do I have a remove in here? Please say I do. Yeah, I actually do. Okay, cool. So let's do remove element from a hash map. And then we're going to say the hash map. And then we only need the key. So if, actually this is going to be the same thing. So add element. If we do not find it, remove, no, if we don't find it, then don't do anything. Actually, I think this checks for itself. Yeah, it does. So I can just call remove. And then we're going to pass in what? The address of, well, I could have guessed that, but address of this table, and then the key. Because we got checking for if the key exists itself in there. Do I have that in add? Yeah, I don't check it here, so you need to check that. And then variable pointer types passing hash table parameter. Oh, yeah. Okay. And then what else do we need? Let's be able to get a value from it. So in this case, it's a boarding pass. Oh, you know what I could do? Yeah, this is blib. So in that to do, make the hash maps and tables generic. The only thing I need to figure out there is how do you print generics? That is the question of the day. Okay, so we return a boarding pass, and then say get value Hashmap, and we'll pass in a Hashmap and the key. Oh, not HD. We're doing a Hashmap here. So here it's just gonna be return find value of the Hashmap and the key. Cool. Oh wait, no, not the Hashmap. The hash table key. Okay, cool. So let's get these over here. Okay, there we go. And then here we need to include this and What? Oh. Right, and then let's hit it with the good old pragma once. Alright, so that's good for today. I gotta go. But let's go ahead and git add, or let's see the status, make sure I'm not adding anything I'm not supposed to. Start of Hashmap. Implementation. Okay. That didn't look right either. Very cool.